Okay, yeah. So I do want to encourage more people to participate on the Piazza. I know there is a lot of participation, but it does seem to be maybe a selection of about 30 people, or maybe about 20% of the class is contributing about 80% of the contributions on Piazza, which you know, I guess according to economic principles, that's quite common and just a natural phenomenon of life. But I do want, I would like some of the people who are on the lower end of the participation to start participating more. There's still a lot of people with 0 contributions. So if you haven't, it's already the 4th week. If you've made 0 contributions on Piazza so far, make it a goal to make 1 contribution this week, okay? You guys are all capable of doing that. I know it can be intimidating to ask a question or answer a question, but if you're in the 0 contributions pool right now, make it a goal to make at least 1 contribution this week, okay? And there's actually a lot of you who only have 1 contribution also. So, and meanwhile, there's about 20 or so of you who have like 25 or more contributions. So, you know, that's great. But okay. Anyway, we'll continue on here. And let's we'll get this going. We're continuing on in Object-Oriented Programming, okay? And so today we'll wrap up this talk of S3, the S3 Object-Oriented System, which is the most important Object-Oriented System in R, just because by its de facto it is the most commonly used system in all of the base packages, and everything that loads up in R uses S3. We will cover the other object-oriented systems just kind of for completeness, but you will not be tested on them, and they'll only make an appearance later on for in a homework assignment later. But all right, so we left off and we said in S3, the idea of the object-oriented system is that you have generic functions, and depending on the class of object, that function will behave differently, okay? And the analogy I used was you have the verb swing, but depending on the kind of object I give you, the way that verb swing carries out will look different, okay? So whether I give you a baseball bat, a golf club, or some kind of rope or something like that, what you do when I say swing will be different. And much in the same way, that verb swing we can think of as a generic function that will have a different method depending on the kind of object that we're given. And so in S3, we need an ability to create new methods, okay? And that is done using this definition here, okay? So if we say function of f, okay, f is a function of x, then this creates a function called f, and if that function makes a call to use method, this makes it a generic function, okay? And so what this tells R is that f is going to look up different versions of itself based on the class it receives. Okay, so for example, so here we have the generic function f, and then all we have to do is we just follow the S3 naming conventions. So I'm going to call this f.a. f.a, by just by the fact it's named f.a, means it is the function f for classes, for objects of class A. Okay, f.a, R will figure this out and say, well, this must be function f for objects of class A. All right, and so this function, all it does is just going to return the character string class A. Okay, that's all it's going to do. Right, but this just by saying creating this, is going to make it the f function for class A, just this naming system. Okay, and so now I'm going to create object A. It doesn't matter what name this is, but I'm just going to call it A. And it's just an empty list. We're using the structure function to create it. It's an empty list where the class is equal to A. Okay, so if I ask what's the class of A, it's going to say it's class A. And then when I run f on A, R is going to recognize that this object here is of class A, and so it runs this version of the function, and it returns class A. Okay. It doesn't seem like much has happened here, but we have now implemented an object-oriented system here. Okay, we have a generic function f, which will behave this way for objects of class A, and we have an object of class A, and indeed it behaves that way. All right. You can take functions that already exist, like for example, the function mean is already a function that exists in R, but it's a generic function, which means it makes a call to use method. And therefore, if you create a function called mean.a, then R will recognize and say, oh, you've given me a function of, you've given me an object of class A, and so I have to use mean.a, all right? And so, so here mean.a is a function which just returns the character string A, and then when we call mean on the object A, which is of class A, it returns back that character string A. Okay. There's no check to make sure that the methods are correct or that anything works out correctly. It's just it just goes. All right. Okay, method dispatch. So S3 method dispatch is done using the use method. Okay, and it's just going to look up what it does is it looks up the function name. Okay. So it's going to just say, oh, what's the generic? The generic is f. We're going to look up f.a, object class. Okay. So here we've got this. All right. We said f is a generic function f. We have f.a, which is the default. Not the default, which is the function for objects of class A. And f.default. Okay. You can't. Or you should not create objects of class default. Okay, this is what's going to run if the object is not found. Okay, so here if the class doesn't have a specific method. So here I've got f.default, which is just going to return the string unknown class. All right. So here I'm running f on this structure. I did it all in kind of one line here. So this is going to create an empty list of class A, and when we run f on that, it returns class A. Okay. Here, I've got the same thing, an empty list. The class is a vector, and it's vector B and A, all right? And so what R does is it looks up and tries to look for a method. It looks for f.b first, okay? But it doesn't find f.b, and so then it looks for f.a, and it finds f.a, which says return the character string class A, and so it returns the character string class A. Okay, and then finally over here we've got an empty list, but it's of class C. R looks up f.c and doesn't find anything that says f.c. Okay, and because there's no f.c and there's no other class assigned to it, it's going to use the f.default, which returns the character string unknown class, and that's what it does here. Is that okay? How this works? All right. Because they're just regular old functions, you can call them as if they were regular functions, right? So here I've got C, which is an object of class C, empty list of class with class C, and then the default will be which is what is the correct method to run. That will return unknown class, but you can say, I want you to run f.a, okay? I want you to run the function that's supposed to be for objects of class A. And you can call it on object C. and it'll run, okay? There's no check to make sure. If you call the method directly, there's no check to make sure that this is what you're supposed to do. It's just gonna say, all right, you want me to use this method? Then I'll do it. It's kind of like saying, here's a baseball bat, but I want you to swing it as if it were a golf club, all right? And then it's gonna do it, all right? And it might give you unexpected results, but you can do that. There's no check to make sure that says, you've given me a baseball bat and you're telling me to swing it like a golf club. That doesn't make sense to me, okay? It just says, all right, you've given me a baseball bat, you've told me to swing it like a golf club, I'm gonna swing it like a golf club, okay? And so it does that, all right? So it just says, you know, this could be dangerous, all right, if you call these things directly, right? So I've got a couple examples to kind of just make sure we got a good handle on this. So I'm not gonna force you guys. Can you guys all see the text up on the screen? Okay. So, well, I know the front row can't see it, but back row, you guys are okay? All right, I got a thumbs up, great. Okay, so in your head, it requires a little bit of addition, but in your head, all right, I'm creating a generic function f, okay, by using use method. And then I've got f.j, which will take the argument x and add 2 to it, and f.k, which takes the argument x and adds 10 to it, all right? So here, I'm gonna create k has the value 1. All right, what will f of k do? Actually, I didn't have this in the notes, so I'll just go ahead and do this because this is kind of an unfair question, all right? So f.k here, f of k, is there a class associated with k? Okay, there's no class associated with it. If we say type of or class on k, it's going to say it's double, type double, okay? And we don't have this, right? So it's going to say there's no method applicable for it for objects of class double or numeric, right? There's no nothing for double or numeric, okay? So what I have to do is I have to make sure that k is one of these things, right? So here I'm going to just assign this object k, which has the value of 1. I'm going to give it class j, all right? Let me just kind of open up the environment, okay? So here we can see k is of class j, and it has the value 1 there. Okay, so if I run f of k now, what will it return? It'll return 3. It's going to call the f.j method, okay, on this, and it returns 3, okay? It also gives back, it's also class j, all right? That's what we have here, okay? Here I can reassign, I can change the class of k to k, all right? This is, so in R, it's very loose. You can just change classes of objects on the fly, okay? Other languages, you're not allowed to do stuff like this. Okay, so now what will calling f of k do? It'll return 11, right? Because k still has the value 1, and now it's going to return x plus 10, okay? All right, so it returns 11, and then I'll, this attribute information, okay? I'm going to create a function called f.default. This is what we'll run, okay? So if I call f.default, or not f.default, but if I call f on k, it's still going to return 11 because right now the object k is of class k with the number 1, okay? What I can do is I can get rid of the class of k, all right? And so if I ask what is k, it's just the number 1 here. And if I call f of k here, what's it going to run? It's going to return 101. It's going to run f.default. Okay? All right, so because k now has no class associated with it, it's not going to run f.j or f.k. It's going to run f.default. All right, and then here we can have another method. This is f.l. This is the function f applied to objects of class L. Okay, and here L is going to be an object. It's going to be the number 10, and the class associated with it will be KL. All right, so just just to kind of refresh what the different methods are. We've got f.j is plus 2, f.k is plus 10, f.default is plus 100, and f.l is 50. And L is this over here. So if I call f.l on this, what will it give me back? Or not f.l, f of l. This will return 20, right? Okay, because L has the value 10, and its class is the vector k and L. And so it's going to first look up f.k first. Okay, and because it finds it, it's going to do plus 10 and gives back 20. If I change the class of L to M and L, okay, I have no method for f.m. Okay, that doesn't exist. So when we call f on L, it's going to look up f.m, and it doesn't find it. And then so because it doesn't find it, it's going to use f.l, and f.l says plus 50. So this will return 60. Okay. F applied to L will return 60. Yes, question?
Will it use the default if neither of them exist?
Yes, if neither of them exist, it will use the default, right? So here, I'll go ahead and do that. I'll say class of L is going to be M and N, okay? So, so L is of class M and N, and if I call F of L on this, it's going to look up f.m, it doesn't find it. It's going to look up f.n, it doesn't find it. So it's going to use the default, which will be plus 100, and we get back 110, okay, with M and N, right? And again, you can call the objects call the method directly on it, okay? So f.j is plus 2, and so you can say, I want you to swing the baseball bat as if it were a golf club, okay? And it'll do that. And again, if you give it something that has no class, it's going to run the default, okay? So here we've got 107, and again, you can force a certain method on it and say, I want you to change it up here, okay? And so the object-oriented system in R it's very very loose, but it works, okay? It's kind of, this is, you know, compared to other languages, the way it says, all right, here's our generic function f, and then we're going to have these special versions of f, you know, based on f.j, f.k, and stuff like that. It works, okay? And it's something you have to be aware of, because a lot of the things in base R use this function dot class name system, okay? So again, when you know, if you just start typing print into R, print dot, you've got all of these different versions here, okay? All right, I'm going to start talking about S4, and I'm going to kind of zip through S4 a little bit quickly, and then we'll also get to reference class stuff, and maybe I'll spend a little bit more time in reference class stuff because you will use reference classes in a future homework assignment, okay? So, but S4 is very much like S3 in that you have generic functions like the verb swing that works differently based on the object you give it, okay? The difference with S4 is that everything is formalized. So in S3, you were allowed to just say, you know, here's this thing, I want to change the class to K, I want to change the class to J, I want to change the class to L. And we never actually said, what is class J, or what is class K, or what is class L. We just said, let's say this is class J, or let's say this is class L. And then you just said, oh, I want to create a new generic function, and I want to create a method, f.a, f.j, f.k. And S3 allowed you to do all of these things, okay? With S4, we've got the same system, generic functions that behave differently for different objects, but everything is formalized. We say, if we're going to have a class called, you know, K, we are going to have a definition of what it means to be of class K. And everything that's going to be of class K needs to fit this structured definition, okay? And so it just adds rigidity to it so that, you know, you don't have these situations where you can kind of just force R to, you know, use the thing in the wrong way, okay? We're going to have a formal definition of what is a baseball bat, okay? And we are, you know, it's going to have to have these exact dimensions and these things. We're formally defining all of these things, okay? And so, again, you don't need to, S4 will not be covered on the exam, and reference classes, which I'll show later, is not going to be covered on the exam, okay? There is the package library methods, okay? And if you say search, it will generally show up there, package methods, okay? However, if you run R in batch mode, which few of you ever do, but it's kind of like you're gonna have like this automated script, and I don't know, you set up this kind of this auto thing that your computer runs every now and then. I don't know, you get some kind of operation. Then these things might not auto load. So this just says call library methods if you're not sure. Okay, with S4, we have a function for is S4. If you call a structure on an S4 object, it'll say formal class, and then you can also use library prior. Okay, so over here, there's library stats4 and library prior. Okay, we'll load these things here. And, oh, I guess, yeah, all right. Okay, and so here I can create this MLE object here, all right? So here, let me actually delete all of this out. We'll do this, okay? And so you can see the result of fit is formal class MLE, okay? And so the result of fit is formal class MLE, whereas, you know, other things like if I so I mean, if I just say model 1 is going to be linear model y defined by y or something, okay, this just gives me back a list of 11, right? So if I say structure of model 1, which was created by the linear model object, we can see it's just a list, okay? It's a list, but it has the attribute where class is ln. Whereas if I ask the structure of fit, which is created by the MLE object, okay, here it says formal class MLE, okay? And so this is our indication that it is an S4 class object, okay? And you'll also notice when you look at the structure, when it's a formal class, when it's a S4 object, it looks similar in that it looks kind of like a list, except you'll notice we don't have $signs, right? So when you look at structure and you look up a list, it shows $signs, but then when it's a formal S4 class object, you get @signs, okay? So you get these different symbols. So these are just kind of indicators that this is a formal class S4 object, okay? And again, everything in the base packages, all of the base packages use S3. So you have to call some kind of package like stats4 or something like that to fit these things. And then you can say, you know, is S4 is fit an S4 object, it's going to say true, okay? There is a function called number of observations, okay? Number of observations is it's a generic function, but it says standard generic, which is different from use method, right? So if I call something like mean is a S3 generic function, which uses use method. When you have a S4 generic function, it gets standard generic. Okay, these are just differences for some of these things. So if you say, is S4 number of observations, that function, is that an S4 thing? It's going to say true, and it's going to be S4 of type generic, things like that. Okay, and then you have the number of observations method for MLE things, and it's defined that way. Okay. So you can see if it inherits this way, what is object fit? It's going to see it's object of class MLE. You can say is fit an MLE object, that's going to say true. And then defining classes, we use this function called setClass. Okay, setClass, and it will have a method called new. So when you create an S4 formal class, this is how it's going to work. All right, you're going to have a name, and then it's going to have slots, which are basically like things in a list, except because it's an S4 thing, we don't call it a list. We call it a formal class with fields, and then what type of what class that it inherits from. Okay, so for example, I think this all just works a little bit better by example here. We're going to create a formal class, S4 class object called person. Okay, this is going to be of class person, and what it will have, okay, is it's going to have name and age. Okay, name is going to be a character vector, and age is going to be a numeric vector. All right. Over here, there's going to be another class, a class called employee, which inherits from person. Okay, it says contains person. Okay, so it's going to inherit from person, and then and the employee. So this employee will inherit everything that comes from person, meaning it's going to have a character and an age. But if it's an employee, it's also going to have an additional field called boss. Okay, and boss itself has to be another person. Okay, so here Alice is going to be a new person where the name is Alice and the age is 40. Okay, and John is going to be a new employee, which means because he inherits person, he's also going to have a name and an age, but he also has another field called boss, and boss needs to be a person object. Okay, and so we can put Alice in here for boss. Okay, but we can't put in just some random value here. Okay, the thing that goes into the boss field needs to be of class person, and so this will work out. Okay, and then again, to access the things, you can say, what is Alice's age? Okay, you use the @ sign, much like the $sign for lists, but for S4s, we use the @ sign. And we're going to say, what's Alice's age? And it says 40. Okay, over here we've got slot John is boss. Okay, what is John's boss? And that's going to say that's an object of class person, and it's Alice of age 40. Okay, and so okay, so this just says you can modify S4 classes, but then you're going to cause problems, right? So here, if we ask what's the structure of Alice, it's going to say it's a person, age, name, and age. Okay, and then we're going to say, you know what? A person is not defined just by their name and their age. A person also has a city where they live. Okay, and so we're going to redefine what it means to be a person. Yes, question?
Yeah, on the C class employee one, you didn't have a slot for each.
In what?
The C class, the second class employee one, you didn't have a object for each.
No, but it says contains person, right? So employee says contains person, which means the employee inherits everything that a person is. Okay. So a person has a name and an age, okay? And we're going to say, here's another class called employee. It's going to inherit everything from what it means to be a person, because employees have to be people, okay? But on top of just having a name and an age, they're also going to have a boss. And the boss also has to be a person, okay? So yeah, I didn't say employee needs to have name and age. It's sufficient to just say the employee is a person, which will contain name and age. Okay? So it's just a formalized system, right? We're just formalizing everything. And so anyway, we can just change what it means to be a person, and we can say a person has to have a name and age and a city, okay? And now if I say, okay, well, what was Alice? Alice used to count as a complete person, but now that we said a person needs to have a city, she no longer qualifies as a person anymore, okay? According to the this is a silly scenario, but according to our rigid structure, this doesn't count as a person because it only has a name and an age, and it doesn't have a city, so this throws an error, right? No slot of name city for this object of class person, right? And I like how they put person in quotes. So that's what's happening there, okay? So it's just, you know, this in S3 this wouldn't have been a problem. It would have just been, I mean, we don't even define what it means to be a person. We just say like, oh, this is going to be class K and class person and class employee. And S3 didn't care. S4, everything now needs to fit all of the rules and regulations. Yes?
In S4, can you give like slots default values if you don't? So if you don't like.
Let me think. I'm not sure. I don't know. To be honest, I hardly ever write stuff in S4 because S3 works like 99.99% of the time, and I don't need to do much else. Okay, but I guess for the sake of completeness, I'm covering this. But it's not that important. That's why I don't even bother testing it. So. But it's here, all right? So it's just here. So I'm sorry, I can't answer your question. Okay, there are methods to create, or ways to create methods in generics, right? Because it's still a generic function that behaves differently based on the object you give it. And then so instead of use method, you use set generic, and it works this way, okay? I'm sorry, not set generic, standard generic. Okay, and so standard generic is very much like use method. But again, this is about my extent of S4 knowledge, just because I don't really use it in my day-to-day. But you might encounter it when you're using a certain package. So just wanted to give you guys some exposure to it. All right, reference classes. These can actually be useful. All right, and reference classes, what they are when you create a reference class object, you're actually creating an environment. Okay, you're creating an environment which is going to contain its own variables and values, and inside the environment, you're also going to contain functions. And so, what this allows you to do is it allows you to have these mutable objects. Okay, and I don't know if you're familiar with that term mutable, but you know, in R, in regular base R, everything you do with a function never modifies the original object. Okay, everything you do, you say, I want you to sum this vector. Okay, it's not going to modify that vector. It returns back a new object. Okay, everything you do, you subset a vector. That original vector remains unchanged, and it just returns back, you know, the subset that you're looking for. Okay, everything in R is what we call a copy syntax. Okay, you give the function an object, it never modifies the object, it returns something else. And if you want to update the value, you have to always use that assignment and say the returned thing, the thing that gets returned is going to be assigned back to, you know, the original thing, right? So if you want to remove data frame, columns from a data frame or something, well, I guess you can null out columns in a data frame. But in general, you know, if you subset a data frame, it returns back an entirely new data frame, okay? And it doesn't actually modify the original data frame. And you have to take that thing and you have to save it as the thing that you want, okay? With reference classes, you have mutable objects, meaning you have an object, you'll run a function on it, and it changes the object itself, okay? And this is, this kind of is different from much of the rest of R's philosophy in terms of how things operate, but because so many other languages use mutable objects, the R base team said, okay, we'll create some kind of system to have mutable objects here, okay? And so here we're going to create something called an account, a reference class called account, and you use this thing called set reference class. And when you use set reference class, it's going to automatically inherit certain methods, okay? So all reference class objects will have certain methods like new that allows you to create new things of this, right? So here we're just, we create something called a reference class of type account, okay, of class account. And here I'm going to say, I'm going to make account $new, and this is going to return a new object of class account, reference class object of class account. All right, so this is how we will define what an account is, right? So we're going to just pretend you're a bank. An account is defined only by its balance, okay? So this is all we're going to have here, okay? So we're going to create account, which is a new reference class, a set reference class, and it's a list where the balance is equal to numeric, okay? So here we're going to say account new, and we're going to set balance equal to 100. All right, and so this is where things will start to behave different from what we're accustomed to, okay? A $balance is 100. I'm going to change a $balance to 200, and a $balance is 200. This part is not surprising. This part is fine. Okay, here I'm going to assign A, right? So A is my account with a balance of 200. I'm going to assign A to B. And I say, okay, what is the balance on B? The balance on B is 200. I'm going to say, let's change the balance of A to 0. And then if I change the balance of A to 0 and I ask what is the balance in B, it comes back and it says 0. All right? So that should feel weird, okay? And what's going on is that A has been assigned to B. So B and A are both pointing to the same account, okay? So all we've done is we've just given the same account, the name B and the name A both point to the same thing. So when I change the balance in this account to 0, and I ask what is the balance in A, it's going to say 0, and what's the balance in B, which also points to the same account, it's also 0, right? And everything else in R, when you do something like this and you say, take A and B, assigned to B, these are not copied. Or I mean, this would normally create a copy. So we would be, if A was a list, okay, and with a list where the balance is 200, and I said assign that to B, B would be a copy of that list, and you would have one list over here where the balance is 200, one list over here where the balance is 200. You change this list's balance to 0, this list balance is unaffected, okay? But over here, because we have mutable objects, and A is pointing to this object, and B is pointing to the same one, when you change the balance to 0 over here, B, which points to the same object, okay, the account, it's also going to have be modified. Is that okay? So if you want a copy, you have to use the method called copy. Okay, so right now, A is our account with the balance of 0, and I can use a $copy. And that creates a copy, and we're going to call that D. So now we have a different account where the balance is 0. Over here, the different account, the original account has a balance of 0. Here we ask, what's the balance in D? It's 0. and I can say, all right, let's change the balance in our original account A to 100, and this changes it. And we ask what's the balance in D, because D is a copy and not pointing to the same thing, this remains 0. Okay, so here in regular R, copies are an automatic thing. Everything we do creates a copy. But with reference class objects, okay, they are not copied. You have to explicitly say make a copy. Yes?
Can you write a $copy parentheses $balance sign 100, and then will that make the D $balance 100?
Oh, you're asking me all these tough questions. I don't know. I think at that point it might just be easier to I don't know. You might have to do it in 2 steps. You might have to create a copy and then change the values that you want to change. I'm not sure. It might be possible, but I think copy just creates a copy. And I think it does accept other arguments, but I'm not 100% sure. Like in Python, which uses mutable objects, there's copy methods for lists and stuff and things like that. Okay. If you want methods, okay, so now with reference class objects, the methods belong to the class, okay? We don't have generic functions anymore. It's not this, here's swing and do something different based on the object I give you. Now it's, here's the object, and this object has certain actions that are allowed, okay? There's only a few actions or few methods that this object can handle, all right? And so here we're going to create 2 methods. One is withdraw and one is deposit, okay? And notice we use super assignment here, okay? And this is a legit use of super assignment, okay? I always say never use super assignment. The only time you should use super assignment is for reference class objects, okay? I know some of you guys use super assignment for tic-tac-toe. That's fine, all right? I've already given you my disapproval, but you did it anyway, so that's fine. Okay, so here what we have is methods is a list, and so the reason why we use super assignment here is because the way a reference class object works is that the object is actually an environment which contains its own things, right? So inside this environment, you have to think of this own environment. We've got a sandbox in here. We have a variable called balance, okay, and it has some number, 200 or 100, whatever it is. And then inside this environment, I'm creating 2 functions here, okay? A function called withdraw and a function called deposit. So when I execute the function that's inside this environment, it creates its own execution environment, right? And so in order to modify the balance that's inside the reference class environment, I need to use super assignment so that the values inside the execution environment can talk to the values up there, okay? So that's what we got. So all we do is balance is going to do balance minus x, and deposit will be balance plus x, all right? And we super assign that back to the balance that exists inside the account. Yes, question?
So how is our set reference class different from just set class?
So the set class is for an S4 thing, okay? And then class is for S3, where you just do things on the fly, all right? And then here, set reference class, they're ways of R to know that you've got different kinds of objects going on here. Okay, so anyway, here we're gonna create a new account. We're gonna call it A. A starts off with a balance of 100. Then I can call this method $deposit 100, and we can ask what's the balance on A, and it will say 200, okay? And so this thing, we have to just know that deposit 100 will modify the values inside A. But because it's in a reference class thing, it's only going to modify what's in A, and it's not going to modify something somewhere else, all right? So the super assignment, there is super assignment going on here, okay? But because it's subject to the reference class, we know that it's only going to modify the things within this reference class object. Okay. You can have reference class things inherit from others, and there's some examples here, but we got through the important stuff, okay? So we'll do that. Okay, we'll see you guys on Wednesday.
actually says